Hi everyone, we have Mr. Anuj Gupta with us. He is a seasoned AI advisor, mentoring large corporations to become AI ready and solving complex challenges that in house AI teams may find difficult to tackle. 20 years of experience transforming AI startups, VCs, as well as Fortune 50 companies. He has helped to drive billion-dollar outcomes through funding rounds, IPOs, as well as acquisitions. Mr. Gupta has also co authored an AI book that is shaping academia and global tech leadership. Hi, Anuj. Welcome to Math. It's a pleasure to have you on board here today. Can you tell us a bit more about your journey?
Sure. At the onset, thank you so much and thanks a lot for having me. My journey is a crisscross across academia and industry. I did my undergrad work for a couple of years, then I did my master's. This is where I was introduced to the whole area of artificial intelligence. So started looking at it from a foundational point of view, and then post my academic friends, I started working in startups very early. Back in the day, the startup scene in India had just started to kind of come up. So before 2013-14, interestingly came across a gentleman that was building a startup which was highly AI focused, and I joined in as a founding member of the team. And that's where my AI in the corporate world or in the industry started to take shape. Post that, thankfully, we were lucky. We got acquired. Went on to set up the AI function for the company where we had moved in. Went on to do similar stuff at a lot of other MNCs where often I was the first person from the AI background, and my mandate would often be to set up AI functions from scratch, the entire AI teams from scratch. And post that, for last couple of years, I've largely been working as a AI advisor, mentoring startups and MNCs get the AI readiness part, as well as solve hard problems which the internal teams are often not able to solve well. So that's a quick and dirty of my journey.
Please tell us more about what your startup Gradient Advisor does.
So the idea basically is that if you look at the traditional software, right? We as a country have mastered how do you build traditional software, right? We have done this for 30, 40 years and understood every aspect of it. Today, building an app or a traditional software application is just a matter of a couple of weeks, right? AI is still far from that. So, based on my own journey, my own experiences across 20 years, Gradient Advisor helps startups and MNCs get AI piece right. This could be from strategy vision to technical implementations to even people aspects, right? What are the right ways to set up world class AI teams? So, this is what Gradient Advisors does.
Anuj, you have done AI in both academia as well as industry. So, do you see any differences? If yes, what are these differences?
Oh, yes, there are a lot of differences, right? So, if you look AI in academia, right, in most cases, you will have a fairly well defined problem. You will also have a fairly well defined data set. The quest in academia is often to push the algorithmic boundaries. Can you build a system that is better and better and better? And that often requires one to create newer algorithms altogether, right? So this is what happens in academia, or I would say research labs, right? So if you look at the deep minds, the open AIs, the FAIR from Meta, and all the academia across the globe, this is what happens. In industry, the focus is completely different, right? Building something that people want, people will pay for it, but solving those problems where AI can play a great role. So this very differentiation creates a lot of difference. So when it comes to AI in industry, at the end of the day, what is the value proposition of your offering, which could be a product or service, doesn't matter, and how will you solve it to elevate the pain point becomes a far bigger question. And this changes the dynamics completely, right? So you may not use the greatest algorithms in industry, which is okay, right? Whatever gets the job done, but it's more about what problem are you solving.
Let's go a bit deeper in the previous about the previous question. Within industry, what differences have you observed when it comes to looking at early stage startups versus large corporations?
That's a great question. Maybe before that, what I'll do is I'll add an example to kind of illustrate the previous point better. This was again the startup that I started to work on in 2014-15, right? And one of the things that we were looking at is how can we look at data coming from social media in order to help brands do a better customer service. Now, a lot of our data used to come from Twitter and Facebooks of the world. One of the interesting problems Twitter demonstrates is that, unlike other languages in the world, which always have a formal dictionary, Twitter does not have any dictionary. People can introduce any term, use any word, maybe even coin new terms, right, to express themselves. And what we saw back in the day was often 20% of the vocabulary will get added every month, which means by the end of 6 months, the entire vocabulary that is being used has changed. Now, when you are doing NLP in such settings, you always require a mathematical formulation that will represent your words and concepts. Now, what you're looking at is gradually a large piece is not even there in your training data because that vocabulary did not even exist when you started. And in 6 months down the line, the entire vocabulary has gone obsolete. This is one part of it, right? The second part of it was how do you formulate the problem itself? So, in this particular case, we were building a customer support system for social media, right? So it's very often today common for folks to tag brands on social media and say, this is not working, that is not working, this was wrong, that was wrong, and stuff like that. And we used to ingest all such data, convert it into tickets, and help brands to solve it quickly, right? So that was a primary product proposition. But here what we realized is that what a brand responds to is not standard across all the brands. While in extremes, yes. So there are messages that no brand will respond, and there are messages that every brand will respond on the two extremes. But in the spectrum, somewhere in the middle, the things become much more murky. So there are messages that one brand will respond to, and there are messages that another brand, same message, but the other brand will not respond to, which means the notion of what to respond and what not to respond will vary from brand to brand. And this is where my second big lesson came in, that how you formulate the problem in industry becomes very important, right? And this is very different if you think from a solutioning point of view, because now what you're saying is that there's no one solution that will fit all the brands, which is very different from a traditional SaaS software. In SaaS, you always had the luxury of building once and selling the same thing to multiple clients. Now, here for each of them, because they have different notions, right? They have different label data, which means there has to be a different model. But at the same time, how do you build a SaaS out of it? So this is where we had to go and create systems whereby they will start in a certain generic way, but over a period of time, adopt to brands. And third, the most important thing that I learned was that you can build a lot of tech, which can be very jazzy. But when it comes to adoption, the most crucial aspects are two. One, is it a pain point or a vitamin? Second is the economics of it. So in this particular case, because we were assisting customer support teams, the value proposition of the product was using our product, a large volume of tickets can be handled by a very small team. So we will help you run very efficient teams. Now, what does that mean? How can you price your product? So because you're essentially trying to reduce the number of people, right? The max you can charge for the product is at a per seat level, right? So in the market, because as an alternative, humans are available, say in an APAC market for $500 a month. For this product per seat, you can't charge more than $500 a month, no matter how good your technology might be. So these are aspects which are very, very different from academia, right? So this was the previous question, right? Coming to the question that you asked with respect to early stage startups and MNCs, the big difference is that early stage startup sees an opportunity, believes that it will grow big. So it's a hypothesis. And you need to test the hypothesis, right? This is typically called as a product market fit. So a lot of startups are gunning for product market fit, adoption, and scaling. While in large organizations, that is already sorted out. But the point is, can you build now features which are clear differentiators, which will give you edge over and above the existing competition in the market, right? So the kind of where you are in your journey, right? A early stage startup has to worry a lot about number of customers, number of paying customers, revenues, and stuff like that. In a large MNC, that piece is largely sorted, right? So that's the key difference, I would say, between the two.
So, one follow-up question to the insight that you've just shared about the key differences on how early stage startups are looking at AI versus how MNCs are looking at AI. How do you see any synergies or any opportunities where startups and MNCs can come together in this evolving AI landscape and collaborate than working as in silos separately as a startup and MNCs? Like, have you explored that avenue?
A lot of MNCs today have created investment arms, which are now investing in companies which are doing work around the primary value proposition that the MNC have. Right? See, today we live in a world where a bunch of very smart kids sitting in a corner of a world can actually create something overnight, which can bring down multinationals at a much faster pace. Right?
Yeah.
They can literally burn down your business overnight. On the other hand, if you look at the primary challenge that MNCs face is that because of the very size, they move slowly, right? So speed becomes the fundamental advantage that a small 4 or 5 people team has over a 4,000 people team, right? They can move very, very fast, right? So this is where the whole idea that multinationals have is to pick startups very early that come up with these crazy ideas. And crazy ideas often get incubated more outside rather than internal, right? So catch them young, catch them early, groom them, and see if some of them can be then integrated. So this is almost a risk aversion strategy, I would say. Not so good part is because once a large early stage startup sees an opportunity, which is often missed by large companies, quickly build stuff, get a dominance. We have already seen this play out extremely well in AI, whereby if you see the developments in the last 2 years, a lot of foundational work was actually done by Google, right? Be it be compute, TPUs, be it be the kind of data sets, or be it be some of the architecture, the transformer architecture. These are all innovations by Google. But it's the open AIs of the world which went on to create the chat GPT, and Google's had to follow up.
True.
Right? So this is where you see the speed, the agility of a startup versus, I would say, the inertia of a large company, right? Uh, and this is what makes new age technologies extremely interesting and lethal for large organizations because you need to move fast in today's world. So in a way, what Google did to Yahoo many years ago, OpenAI has now gone on to do to Google.
Yeah.
And who knows, tomorrow somebody else will do to OpenAI of the world and stuff like that, right? Large companies, and that's one big advantage they have over startups. Startups are always cash flow. Multinationals always have huge amounts of cash, right? So this is where you see a lot of acquisitions, and I think you'll see this year in AI. I think the first wave of building AI products, 2 years has already happened. I think 2025 will be more about consolidation, right? A lot of startups are not going to make through, right? Because they did not necessarily build the right products and stuff like that. But the ones that did, some of them will get acquired by the bigger players of the world. it also depends on how the economy plays, because if there is enough funding, you'll see more and more startups come in. But if funding starts to dry up, then naturally a consolidation will happen. So this is where, in a way, that collaboration does come in.
Makes sense. So I think from a startup's perspective, that agility, the competency of the team, as well as the innovation that they're working on is working in their favor, as well as MNCs shouldn't be complacent, but also look towards startups if they want to disrupt and stay as the leaders in the industry. So Anuj, tell me about in the evolving AI landscape, what are some of the biggest challenges that industry is facing today?
It's almost end. We are at the first week of December, right? So it's almost 2 years that the GPT moment happened, right? And one of its biggest contributions was, prior to GPT, you had to go and sell AI to a CXO. Now today you don't have to do this. They already know AI is a differentiator, right? How to use it is a separate question, right? But they already are convinced that AI is a game-changing technology. And which is why if you pick any team today, they're already doing a lot of experiments and work with AI technology. I think the biggest challenge that comes are a couple of them, right? One is, like I said, the first wave of building AI products and services is over. A lot of stuff that got built during last 2 years was what I would say as toys, right? Those small utilities, small apps have a small advantage or which solves a small problem, but that's not strong enough to kind of stay around, right? Or, I mean, just to give a concrete example, so imagine somebody builds an application today which will create an itinerary for you because you're traveling, right? So you can always say, yeah, I'm traveling to such a place and I have such a preference, right? I'm traveling for 5 days, create an itinerary for me. Now, this is a great tool. Prior to this, we never had such a things. You often had to go on net, do a lot of R&D yourself, right, to create an itinerary. Today, this can be done within 2 minutes. It will create a very nice itinerary according to your preferences, what are your likes and dislikes. But is this a product? Unlikely, right? This is one of those gimmicky things where people will come, use, but people are not going to come on a daily basis and keep using it. Next question, how many people of those that are using, how many will pay? How many will be repeat payers? Are they going to go and refer to other people, hey, why don't you try this app? This is a great app, right? So these are also known as the three primary things that YC always says to its founders. You always have these standees that say, build something that people want, something that people will pay for, and something that people will refer. So there's a network effect that will come in, right? So first thing is, what problem are you attacking? So this is one example of it, right? I would pick rather the extreme of it. If you look at one of the big success stories, I think probably the biggest success story, which not a lot of people even know is of AI, is actually in pharmaceutical industry. So drug discovery is a very big challenge. Often creating a drug is a 20-30 year game, multi-billion dollars go into it, and maybe 18th year or 22nd year of the trials on, you find that the drug has failed, right? So much time, energy, resources spent, and then nothing happened. And COVID has already shown that there could be black swan events where you may not even have such kind of a timelines at your luxury. Now, what people were able to very smartly do is that they actually use the hallucinations of LLMs as a way to create newer compounds. So it's almost like I conjure up a compound saying that if you add 2 grams of this, 5 grams of this, 13 grams of this, blah 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 blah, you will come up with a compound, and that compound will be able to solve this particular disease. Now the tougher part in drug is to come up with these conjectures, if not the validation of it, because once you have a recipe, you can always create And you can always test whether it has the kind of effects, both positive and negative, that one is looking for. But coming up with these conjectures is always very difficult, especially if it's a very newer kind of disease that we have no idea about, right? COVID was one such. There's hardly any pre 2020 literature on COVID as such. There is a little, but not much. Now, this is where AI played a beautiful game, where it could come up with conjectures which can be validated, because of which the whole timeline that is needed to build a drug has been squeezed. And because it's a multi billion dollar game, even if you move the business needle by 2%, that's still multi million dollars. Right? So the impact is huge. So, first point is the use case. So, I think that's one thing that is plaguing industry still. We're still going after a lot of, in the name of low hanging fruits, use cases which often end up as toy examples. So, the app around creating an itinerary can't be a product. It can be a feature in a travel aggregator's product, but it can't be a product on its own. Unlikely, highly unlikely, right? So that's one part. One is the use case. Second is that AI efforts are happening, but in the business, ultimately what matters is, did you impact the business numbers? Either the number of active users you have, the number of users, revenue, whatever is your North Star of the organizations, wherever they are in their journey. Because if not, then that effort doesn't necessarily make sense. So the ROI is still a very big question mark in industry. Now that's not because AI does not have the power. In my humble experience, and this is something that we specialize big time on, is how do you build AI efforts that leads to large ROIs, large revenues, right? Because if not, it won't add up. Sooner or later, it will be shelved, right? The third is that if you see what has happened in last 2 years, prior to, I would say, 2022, if you had to build AI, you need to have an AI team from day one who will build something for you, which you will then incorporate and show. And they will take at least 3-6 months to even create a V0 of that system. Now that is no more needed. You don't need an AI team to start with. The LLMs, the open AIs, the open source models by Meta, all of them offer what I call as off the shelf intelligence, which is available in a plug and a play manner or capacity. So, a very smart business leader with some crazy ideas, a very smart product leader, and a couple of AI engineers can assemble together a V0 and can be taken to the market very quickly. So that is what you saw from 22 to 24. People could create quick utilities, demos, 2 days, 2 weeks times, which is why so many AI startups came up. But then if you can do, then so can others do. So where is the moat? Where is the defensibility, right? Defensibility, in my experience and understanding, comes from 2 points. One, what problem you are solving. If you are solving a very deep problem statement, you will see the adoption. But beyond a certain point, what will happen is they will start asking you better performance from your AI systems. And this is where you can no longer continue to use these off the shelf intelligence, right? You can do fine tuning, do a lot of techniques, but beyond a point, you can't go, right? You can push the boundary only so much. And this is where you'll have to start building your own AI system from scratch. And in order to do that, the biggest impediment is not talent, but it's data. So organizations that understand this very well have a very comprehensive data strategy in place. So while they are taking this route of building very quickly, there's a team already which is gradually assembling the data aspects of it. Right? So the analogy that I use in order to explain this to CXOs is that you're trying to create a Michelin 2-star restaurant, right? So that you can serve the very best food to your uh, users. A Michelin two-star restaurant will always have a great pantry. So the Michelin two-star restaurant here becomes a business. The chefs becomes the AI researchers. The pantry becomes the data set. But somebody has to put together this pantry, which means somebody has to go source these from the fields, get it packed, bring it to the warehouse, get it open, get it sorted, get it cleaned, get it arranged. This is the entire data pipelines or data operations. If not just machines doing it. These are not large data systems alone. There's a lot of manual aspects also, right? So teams that have mature AI ecosystems will have very nicely done data operations and in this entire pipelines. Because if your ingredient is bad, no matter how good is your chef, your food won't be great. This is very true for AI. You can't just say, I'm going to feed any data. You can use the greatest algorithm, it can't do much. Right? So the two have to come together. Of course, you need a great algorithm, for which you need a great team, which is chefs in this case. But you also need very good raw material. So the moat comes from here. And I think these three pieces themselves, I would say, plus to a degree talent, but talent is not such a big thing. Of course, great AI talent comes at a price, at a very premium price right now. But I would say these three far bigger issues. So, right use case, are we solving the right problem? It is not about are we solving it rightly? That's a separate question. But if we do everything well, then whatever we're going to deliver, how much value proposition it has for the user.
Makes sense.
That's one. Second is the ROI part. If the business does not see outcomes, the hard business outcomes, that team and that work is a liability, not an asset. And third is the data game. It is the data game. It may not start on day one, but that's where the moat comes from. So if you look at companies that have been doing this for the longest time, the Google, the Microsoft, right? Look at TikToks. They're all after data, 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 and data. The foundational reason is that in computer science, you cannot patent an algorithm, which means if we develop an algorithm today, tomorrow the same algorithm will be used by a competitor and I can't stop them from doing that. You can always patent a system. Second, data becomes a proprietary thing. So these two then, even from a legal standpoint of view, right, becomes the moat.
And act as a protection layer actually for
Yes.
companies.
Yes.
Makes sense. To also address like from one more perspective of challenge, in one of the recent interviews by Sam Altman, which I was watching, he was talking about today there are two types of companies. So one, companies that are using ChatGPT and building, as we call them, AI wrappers, right? And then there are other set of enterprises which are not using ChatGPT, trying to build their own LLM models and trying to disrupt that industry, trying to be competitors for OpenAI in specific. So his reasoning was that if you are building on top of our LLM, then you're going to build greater products and you're going to sustain longer. Whereas if you're trying to do something from the very grassroots level, you might not scale up as quickly as we are doing. So what is your take on this?
See, you have to understand why he says what he says, right? So one is building foundational models is a very expensive game.
True.
Okay, most can't do that. From a talent point of view, from a compute point of view, from a data point of view, right? Very few people know that OpenAI, there's a company that was used to label data for OpenAI, which in turn went on to almost whole of Africa was labeling internet indirectly for OpenAI for over 2 years. That's the scale at which you have to get data labeled. Just that sheer magnitude itself is baffling. Then the compute price of it, then the talent price of it. So very few can build foundational models. So there are a couple of them which are trying to do, right? And even there, you see two different approach. One is the open AIs of the world, which are keeping this as a close guarded secret, while the other end of the spectrum is the Meta, the strategy from Meta, which has said we will make all of this open source, right? Which I think that's great for the ecosystem because that ensures there are no monopolies here, right?
Yeah.
But on the second part, I have a slightly different take, right? Even if somebody is building using wrappers, where is the defensibility? What I can do, the other can also do. So imagine if I paid twice to your engineer, the same guy, right, and get it built. What can you do here? You can't do much, right? So this is where the points that I raised earlier come into huge play, right? If you solve a problem which is a real pain point, so much so that your customer will be like, okay, I'll pay for it, dude. It doesn't matter to me because it's such a huge pain for me, right? I end up. So one example is, right, I mean, we are recording a podcast right now. Look at the amount of time and resources it takes from the raw podcast to the processed podcast to go on YouTube. It's a huge effort. Now imagine tomorrow there's an app that says that upload the raw podcast and in 10 minutes I will take care of this. Or even if I take 1 hour, doesn't matter. But that's so much improvement. Your life becomes so easy. Imagine so many content creators will suddenly come up who will be more than willing to pay for this. Right? So that's the kind of value proposition you have to have. So that's one. Two, you can do as much as AI you want, but you need to move the business needle. Right? And it will all come down to revenue and P&L at some point in time. Right? You can avoid that question early on, but eventually this question will catch up. So I think the sooner the better. Third part is the defensibility of it. Right? Eventually, because these wrappers are not perfect, OpenAI's its own models are not perfect. They are not going to give you 100% correctly. No AI system today can be 100% correct. But your end user does not understand that. The end user has been using software for 40 years. We have a certain expectations from it. Now, suddenly, because you have this technology which is stochastic as opposed to the software 1.0, which was deterministic, so be it. I, as a user, don't care a damn. I want 100% accuracy, right? Which means you'll have to push the boundaries of your AI system, which means you can depend only so much, or these off the shelf intelligence with all the tricks in the trade can only take you so far. It cannot take you to the summit, which means at some point of time you'll have to start building your own systems, right? And the only thing that will differentiate over there is data, because compute expensive, but you can throw money and get it. Talent, of course, expensive, you can throw money, but data, you can't throw money and acquire data. It has to be carefully collected. So if we go back to the example of the pantry, right? I can't just throw money in the market and say set me up the pantry. Somebody will still have to go to fields, talk to a lot of farmers, procure raw material, figure out where the best potato grows. Right? Not all potatoes can be used to create fries. We all know this. Certain kind of potatoes that are better as opposed to other. Get all of that collected. Get all of them to your warehouses. Some of them will be spoiled. You can't put all of them. So somebody will have to open all of that, sort, clean, and this is a very massive operation.
We have to agree that data is the new oil.
Yes, right. So the way to understand that is, and I think that analogy should be here. Data is the new oil, absolutely. But when was the last time you rode your car with the crude oil? Try and put crude oil into a car and run for a day, you'll know what I'm saying. What is needed is a refinery that takes in the crude, breaks into various components, right? And depending on what vehicle you're driving, you use the right component. So aviation fuel is different from petrol, is different from diesel, is different from gasoline, right? So this refinery is what again I'm talking about. Very few companies even know such a thing is needed, right? And this often becomes a moat then, right? Because this takes time. what Googles of the world have been doing, collecting data for 20 years. Can you go and buy all the data in one day? No, you can't. You absolutely can't do that. Right? So what I think you will also start to see, and some more people have already started to do, is data collection work. And I think it will be very interesting to see the Motorola acquisition happened for its patent, not for its products. I think we will also see a couple of acquisitions for data and nothing else. A company A acquires a company B for nothing else but the kind of data company B was setting. Because that's so hard to do. There are still no shortcuts to it. A couple of people will say, what about synthetic data and all that? But there are enough papers that have already shown that there is a clear difference between the natural or the real data versus the synthetic data. And if you feed all these models with synthetic data, they start to perform very, very badly. So that example where yes, data is the crude, but always remember next time you say this, try and come to office by putting crude into your car, and you'll know exactly what I'm saying. What you can put is a gasoline, so somebody have done that hard work for you, separating the gasoline from crude, and that is what powers your car.
True, can't agree more. So, Anuj, you also work to conduct masterclasses for CXOs, for venture capitalists, as well as startup founders. Can you share some of your insights with your interactions with these various stakeholders?
One of the key challenges today lies is that a lot of CXOs, a lot of startup founders have built very successful startup and very successful software products. And in a way, they believe that AI is also just a software, which is also true, right? Ultimately, it is the code which is running in a machine that does all this, which is what a software is. So they tend to believe that whatever they have learned and absolutely mastered in building software so far can straight away be applied to AI and done very quickly. Unfortunately, that's not true. All the software that was built so far was largely deterministic systems. AI is a stochastic systems. Now, this is a small statement, but its impact is very profound. What does this mean is that you can never build perfect systems. No matter what you do, if a traditional software gives the wrong answer, it is because somebody did not do their job well. Either the product manager did not collect the requirements, or the engineer created a bug, or the tester did not test the product in it, right? So somebody did not do their job correctly, which is why it's called a bug. Something did not go as it was expected. In AI systems, you will always have scenario where it will not go as it is expected. But that's not a bug. That's not because somebody did not do their job well. It's the very nature of these systems. So how do you sell software which is far from perfect? And your end user will not understand that. I want to take my photograph. I want to beautify using AI. I want to beautify. Now, because I took it in the evening or in a certain specific kind of light, or I was wearing a certain kind of clothes, or the background was a certain type, it may not perform as well. I don't care a damn. I, as an end user, want it perfect. This changes everything. So one of the best examples that I can give that is a lot of companies have tried to build products around virtual try-on. How will a particular clothing or an accessory will look on me? Can I use a software to kind of project that and then use that as a way to buy? None of them have gone on to be successful. And there are multiple reasons for it. One of them is that ultimately the buying decision is nothing but an ego boosting decision. I buy a particular shirt because I look great in it. Nobody buys a shirt because I look extremely bad in it. Nobody does that, right? So eventually the software have to make it look very beautiful on you. Now when the software does not perform, the AI system does not perform the way it is supposed to be for various other reasons, I will look bad. Because I will look bad, I am never gonna buy it. A lot of leaders don't understand this stochastic versus deterministic changes the entire playing field. It's almost like, if I can use an analogy, try and play football not on a grass turf, but maybe on a ice. Everything is same, only the layer on which, or the very surface on which you play has changed. But it's very easy to say this one change will change everything. The kind of skill that is needed, maybe the kind of rules also, the kind of gears they will have to wear, and everything will change, right? Whatever you might have learned or taught while playing football on a grass surface will not apply to this new football which gets played on ice. And all the playbooks, all the best practices, the do's and don'ts of building traditional software do not apply to the AI world. So this is the biggest difference that I've seen, which is why these kind of efforts are even needed. Because people at the very top are the ones who have the authority, they have the budgets, they are the ones who create initiatives, fund initiatives, take it further, and stuff like that. Now, AI is this funny technology where it's a double edged sword. If you don't do it right, your efforts will not lead to business outcomes of no use. Does that mean that you should first sit and wait, let it become perfect, and then I'll do? You can't afford that. Because a bunch of smart kids somewhere in the corner are already sitting and building something which will burn down your business very quickly. Which means you have to be ahead of time. Which means you have to start thinking very, very seriously, how can we use AI to impact our top lines, not just bottom lines? You can't wait for the technology to become perfect. So the technology is imperfect. There's no two questions about that. But yet it is extremely powerful because it opens up a whole new set of problems that can be solved far better that a traditional software cannot. And that's the race that we are seeing now. So I think more than anybody, it's the CXOs at the top, right, who have a lot of responsibility, right, to be proactive more than ever. And when a lot of them are not able to do often for various reasons, because large organizations have certain ways of working, you see a lot of CXOs are quitting jobs and starting startups. So that's where that speed part and that's where the proactiveness comes in. So if you are a CEO, or you are a CXO that has a lot of influence in your org, I would strongly suggest one of the key things you must proactively look at is how can we use AI to impact our North Stars, the top line. I think that should be your topmost KPI today. You are not like, okay, I'll still run with my KPIs that I've had last year. That you may want to, but one KPI every CXO must have very clearly is what are 5 potential AI initiatives that I must run which will impact the top line of my company. The sooner you start, the better it is. Then there is no other way than this.
With your extensive work with CXOs and startup founders, what is that one advice you would give to startup founders today?
Now is the time to build. No matter who you are, you're a startup founder, you're a CXO. It's one of those golden opportunities, right? And the next set of unicorns, the next set of business leaders are all going to come from deep tech. There's no better time than now to, like I discussed earlier, you have to be proactive. You can't be sitting and waiting for the technology to become perfect because perfect AI is almost like AGI. And that could be 5, 10, 15 years. Nobody can say. I mean, I'm one of those who does not believe that we are just 2, 3 years away from it. No, I think we are far from it. Which means here is a new toy which is imperfect but extremely powerful. And this is not just true for businesses. This is true for government agencies. This is true for countries as well, right? Which is why, if you look carefully, anybody who understands its potential, right? If trying to make the most of it, even as countries. The countries were very clear AI is the game that we want to focus on, right? So that's the third part of it, right? Which is you have to proactively start this because it's going to take time. Because it is imperfect, it's going to take time. It's going to take time for you to come up with the really solid stuff. Last and not the least, I would say, is that you have to understand the difference between a model and a system. A model is the very heart of an AI system. I'm not debating that, right? But if I were to take an analogy, I see this very similar to aviation in 1920s. Right? The World War One saw the first time use of aeroplanes in the war. The war is over. What you now have this new beast, right? And that has a lot of business opportunities, right? Now imagine somebody builds a very great engine, which is a very great AI model. If I were to strap a seat to this engine and ask you to take a flight from Delhi to San Francisco or from London to Paris, would you take it? No. What is needed is a full aeroplane for it. So that's like your AI system. You pay as a customer, you pay for that. The system delivering the value proposition. In the case of aviation, flying from one place to another, either as a human or as a good, right? Either of them doesn't matter. Which means you need an aeroplane, which means you need a cockpit, you need a landing gear, you need the wings, you need the fuselage, you need the tail, and you need all other parts. None of these parts were great in 1920s, far from it. But people assembled an aeroplane, made it fly, made it land, started that whole business of it, and then kept improving and kept improving and kept improving. So this obsession with a great model on day one is like obsession with a great engine on day one, right? It took years and years of work to got to the kind of engines we have today, right? It did not happen overnight. In AI also, you can't get to great AI models overnight. It will take time. So start focusing on systems and not just the engines. And the value proposition is always delivered by the system. And a system has a lot of other parts. A lot of teams don't necessarily know that AI systems require a very specialized UI because they are stochastic in nature. So one example of that is when you type in Gmail, there's this auto suggest feature, right? There's a reason why it suggests only a couple of words, but this suggestion is in gray, not in any other color, because it's a soft suggestion to the human, not overpowering the human, because then it would have been in black. When you use this feature in a laptop, it suggests only a couple of words. But when you use the same feature in a mobile, it suggests a couple of lines. Same problem. It's the same problem statement. But the difference is we use mobiles to reply to emails which are typically 2-3 lines long. Nobody can write a 50-line email on a phone. Nobody does that. So there, the way this has been positioned is, I will quickly help you write those 2-3 lines and get on. But if you're writing a 50-line email, getting all those 50 lines correct is a very hard problem. It's better to keep suggesting next 2-3 words and keep on helping you. So this is problem formulation. This has nothing to do with the modeling part of it. So don't get over obsessed with an AI model accuracy from day one. That's a journey. Going from a model to the model is a journey. It's far more important to focus on, are you solving the right problem? Going back to the three fundamentals that Y Combinator always teaches.
Anuj, you have co-authored a landmark book called Practical Natural Language Processing. Can you talk more about this book?
So this book is basically nothing but a lot of insights that I talked, right? So, like I said earlier in the podcast, right? I was extremely lucky to start doing AI very, very early in industry, right? And I realized long back that The way AI is done in academia is very different and has to be very different from the way AI is done in industry, right? So when we were building AI system, and when I say we, me and my co-author Harshit, who also multiple time founder of startup founder, it was very clear to us that a lot of things that we read in academia, right? And both of us have been trained rigorously in academia, right? Harshit went on to do his PhD from CMU, uh, and I did my own. A lot of things that we learned in academia does not work in industry at all. And like I earlier explained, right, because the very objectives are very different, right? In academia, you're trying to perfect an algorithm, push the boundaries of the human knowledge, right? In industry, you're trying to build a product that will really sell very, very well, right? These are two very different pieces. So the needs of industry are very different, right? And it so happened, I remember very vividly that both of us were giving talks in a conference, and we were backstage just sitting and chatting. It was very clear to us a lot of things that a lot of people are coming and saying on the stage doesn't add up. This is all the glorification or not necessarily the ground realities of industry, right? And that's when the idea of the book was born, that what is needed is a book that addresses how do you conceive, how do you build, how do you scale AI systems when you're part of industry as opposed to research labs. Right? So that was the whole idea. And in our case, two of our other co-authors, both Soumya and Bodhi, had extensive background in NLP. All of us had done a lot of work in NLP systems. So NLP became a way to explain all of our learnings, right? So if you look at books in NLP, there are books like written by Martin Zarafskis of the world, which are taught at course textbooks in the best institutes, the MITs, the Stanfords, right? They tell you the foundations, the very underpinnings of these systems. On the other hand, you have these books which are like NLP with TensorFlow, computer vision with PyTorch. We call them as cookbooks, right? These are ready-made recipes, right? But we felt that the need of the industry is somewhere in between, right? Imagine I'm a product manager. I've been tasked to build an AI system. I don't even know where to start. How do I start thinking? Should I go and read Martin Zalewski's? I can't. I don't have the time, right? Should I start looking at those cookbooks? They already have a well-defined problem. Everything is there. It's all about writing that code. There's a lot of work that needs to be done prior to it. Hmm? So the book essentially tries to put forward this point of view. If you are part of product teams as opposed to research labs, how do you think? How do you conceive? How do you create, scale, and iterate AI systems? That is when the that is what the book is all about. Extremely fortunate and lucky that the book has been endorsed by some of the topmost AI leaders globally, coming from Carnegie Mellon, UCSG, DeepMind, Google AI, Microsoft Research, YC Startups, and many, many more. The most surprising part for all of us is that the book is almost now 4 years, or rather 4.5 years old, in an area that is changing literally by the day. The book even today resonates with a lot of readers because we were able to touch some of the foundational questions with respect to stuff that is needed when you're part of product teams and industry, right? So it's more about the trenches of industry when you're there. How do you navigate all of that aspect, right? Which is where I think the longevity of the content also essentially comes. The book has already been published in 5 languages, has more than 250 citations, has often been among the top 1% books globally in AI.
That's wonderful. And who do you think would benefit the most by reading your book?
Like I said, right, the book is about how do you start even conceiving, thinking, right? So product managers, leaders, right, because they have to start initiative. But at the same time, this will also be extremely useful for a lot of ICs, because one mistake that I've seen that a lot of ICs do is that they start implementing the most jazzy algorithm or the most state of the art algorithm, as it's called, or the most hot algorithm on day one for a particular problem, right? AI is not about that. AI, one of the fundamentals that we were taught back in our foundational days in academia is something called Occam's razor. Occam's razor essentially says that if you have two solutions for the same problem, then the one which is simpler is far better, right? Which means your job is to create not the algorithm or the system, but the simplest system that will solve the problem very well. And this is a point that the book emphasizes a lot, right? Because it looks great on the CV, but maintaining AI systems is a beast of a problem. Maintaining traditional systems is a problem already because of the technical debt and a lot of other challenges. Maintaining AI systems goes to a different level altogether, right? Which is why building the most simplest solution, which will get the job done, is a very, very important aspect, right? So this book is for anyone and everyone who is part of AI teams, right? It may not talk of the most latest algorithms, right? But what it surely talks are a lot of foundational principles that you have to get right to build, I would say, more realistic systems in industry.
Thank you once again for coming to Math, visiting us, and sharing your
Thank you.
insights. And we really can't wait to actually get our hands on your book and also sharing it with our AI founders at Math Lab. And also, we can't wait to look forward to further more podcasts with you here. So,
Thank
thank
you
you.
so much.
Yeah.
Thank you for having me.
Yeah.
Thank you for all this time.